Hello everyone. Today we are going to solve this question number 268, missing numbers. Given an array nums containing n distinct numbers in the range 0 to n, return the only number in the range that is missing from the array. In this question, what we have to do is will be given an array with numbers filled between 0 to n, and we have to find the number that is missing uh, in this range. So according to the constraints of this question, it's almost guaranteed that a number will be missing. Let's see how. So as we can see over here, this is an example I designed. It has array of size. It's an array of size 6. Okay, so it will be having 6 places to hold, but the range of values belongs from 0 to n. So there are total 7 values to fill, and the size of the array is 6. So it's a guarantee that one of the number will be missing. So what you have to do in this question is we have to iterate through this array first. Okay, so let's slow down and we will see what's the brute force approach to solve this question. To a brute force approach to solve this question is first we need to iterate over this array once. Then we'll have a variable bool variable that will check if the number we are checking exists in the array already. Then bool will become true, and it won't be the answer. But if the found variable, the bool variable is never corrected to be true, then uh, that index will be our answer. And another thing that I realized that if we traverse through the whole array and we never found the missing value, that means the missing value is n. As you can see here, if we iterated over whole k and didn't found anything, then we return n as it will be a missing number. So as you can see, in an array, let's say for example, if we had this as 4, okay, and this as 0. In that case, what will happen is we will iterate through the whole array and we'll find index 0, index 1, index 2, index 3, index 4, index 5. But we won't find 6. Okay, so 6 will be your final answer for this question. Okay, so let's see how we can solve this question in code. First thing, we need a utility as in n is equal to nums.size. Then first we have to iterate through the array. Iterate. Okay, so for int I equals 0, I less than n, I plus plus, we need a bool to check it. So bool found as false. Okay, now what we have to do is iterate through the same array again. So we'll use another method to iterate, like for int num given nums, if num equals index, then if the number is found, then what we have to do is we have to convert found to true, and then we have to break through uh, this in a for loop, because now running it wouldn't make a sense. Okay, and then we have to check if not found. This means if the value of the found is not true, okay, or else we can write it simpler way. If found is not equal to false. Oh, sorry. If found equals false, then we return I. And for the condition of this one, right, this case where we have 6 as our answer, the n one, is for this, we in the outer loop, after the outer loop, we have to keep a return n, so that if it never founds inside the array after traversing the whole array from this, we can always get the answer from this part. Okay, because after traversing, obviously if it can't find, then n will be our answer. Let's run this one. let's submit. So we have solved this question with O of n square complexity. Okay. The second part will be a simpler version of this, which will be for this one we have O of n square as a time complexity. The next part will be having O of n as a time complexity, O of n log n as a time complexity. So let's see what we have to do here. So to solve it through a second method, what we can do is we can use a sorting approach. What a sorting approach is, uh, in this approach, what we'll do is we'll sort this array. Okay, so after sorting the array, we can traverse through the array again, and we'll match if the index value here and the value inside the array isn't same for the first time. Okay, for the first time is very important, because after that also the values won't be same. So for like here, the first time we found that the value inside the sorted array and the index are not same. So in this case, the first value that we found, the index that we found will be the answer. Okay. uh, the other all the constraint are almost same, written over here as the same question. Okay, so let's solve this part. This time we'll be using sorting method. Okay, so in the sorting method, what you have to do is first you have to what we'll be using an inbuilt sort function, sort nums dot begin comma nums dot end. Okay, and after the array is sorted, what you have to do is we have to iterate over this array for int I equals 0, I less than nums dot size I plus plus. If for the first time, if um, I is not equal to nums of I, return I. And if the whole thing is already traversed and we haven't returned anything, that means our answer is the same as return n. Like in last case, that when we solve through brute force approach, the same way we have a return n here over. Okay, so we have to define n over here too. Int n is equal to nums dot size, and we can clean this part to n. Okay, so let's run this one first. Okay, so it's run. Let's submit this one, and this one is also submitted. This one takes time complexity of O of n log n, and both of the approaches we discussed till now take time, space complexity as O of 1. Okay, because we are not using any new space. In the last one, we only used a bool variable. Other than that, we didn't use an extra space. Okay, so these were the two methods discussed. Now there's a third method which is more efficient than this one, but it also takes uh, more memory space. Okay, so the third approach here will be a hashing approach. This will take a time complexity of O of n and space complexity of O of n. The same question, the same constraint over here. This time what we are going to do is we are going to create a vector bool of size n plus 1. Why n plus 1? Because we are storing from 0 to n. Okay, and we'll store all of them with variable false. And then what we are going to do is we are going to iterate over nums, and if they are found, then we are going to mark them as true. Then we are going to mark them as true for that index. Then we are going to iterate again and now find which of the index for the vector was false, and that index will be our answer. Okay, so let's code this one and then we'll explain. Okay, so let's refresh. Okay, now we'll be using a hashing approach. In this, let's make a utility. Int n is equal to nums dot size vector bool present. I named it as present is equal to n plus 1. N plus 1 gives its size and false as its value. So imagine that you have a box and like vector, and all the values inside it has false inside it, and the box is of n plus 1 size. Okay. Now we'll iterate over it. So for int n nums given nums present of num is equal to true. Using this, for each of the index of num, we have filled them as true. Now again we will iterate over this. So for int I equals 0, I less than n I plus plus, pres we have to find if present of I equals to false, return I. And once again, if you have iterated over the whole array and haven't found the answer, then the answer will be return n. Okay, so let's run this one. Yeah, it's done. Let's submit this one. So this one takes O of n time and O of n space, of n time as and O of n space. Okay, it's written over here. That's it. This time we have solved these questions through three approaches. In the next video, we are going to solve with a better approach that takes less space complexity. Okay, thank you.